How do you sort out the so-called jargon from real-world practices that work? Do the members of your organization find some business advice utterly confusing? Welcome to the 2020s Enterprise with Sam Holcman. In this program, we set the record straight and in terms that people at any level of business and technology can understand. Now, here is your host, Sam Holcman.
Welcome to this episode of the 2020s Enterprise. I'm Sam Holcman, and today's topic is artificial intelligence. And the phrase that we're starting to use with our clients is perhaps it's better called augmented intelligence, augmented intelligence. And the term itself was coined many years ago, actually in 1956 by a gentleman named John McCarthy. And we can even go back a few years prior to that, to 1945. What kind of artificial intelligence do we have there? And a person named Vannevar Bush, I hope I pronounced the name correctly, in his work called As We May Think, proposed a system, please remember 1945, systems ? Which amplifies people's own knowledge and understanding. Lots of years as we sit here in the 2019-2020 timeframe. And so the question is, where should we be? Where are we? Where would we be? And where do we go from here? And the reason for this topic is, just like everything else, there's some very positive things going on in this world, but we're also seeing some troubling trends here. And I'm going to summarize this broadcast by two things that need to be amplified significantly. And it has two words associated with it. That's it. And that's the requirement of traceability and transparency to conclusions. Traceability and transparency to conclusions when it comes to decision making using computational and computer techniques. And a number of reasons why this isn't happening right now, I believe, is underlying the issues, that are sort of happening here. Now, what we're going to be trying to do initially is let's try to define what this is. And it may be a little difficult because if you go out to your favorite popularity contest engine, also known sometimes as search engines, you'll find that there are upwards, I think, of 26 million definitions. That is not a funny or joke statement that's there. So we'll try our best to come up with what I believe is a human consumable definition for this particular area. And we'll talk about some of the positives and unfortunately some of the negative developments in this field. And by no means are we there to say, oh, geez, we've got to get rid of this stuff. The world's going to come to an end. Just the opposite. We have a lot of opportunity to address this because I believe that this will have some serious, tremendously positive benefits in society, but there's a lot of madness out there that you and I need to have somebody address because most of us are not, in quotes, in charge, close quotes, of this particular area. We have literally decades now of learning about artificial intelligence, and that's why I'm using the word augmented intelligence probably is what we're going to be suggesting to people is either the end state or a path to the word artificial eventually. It sounds kind of funny, I think, when I say we're learning and have spent literally decades learning about learning, which is artificial intelligence. But the underlying question, and I'm not going to be here to answer this, is can a machine actually learn? And who and from what are they learning? So obviously we have some definition issues. What is actually learning that's there? And of course, we can't forget the phrase garbage in, garbage out. And that's some of the things that are unfortunately underlying the negative sides of what we're going to be talking about in this broadcast. And what we'd hopefully move to is good stuff in and better stuff out. And when it comes to this area, and our audience, I don't know exactly what all of you know about this, but some of you, or most of you, have probably heard about a very short-lived thing out there called TAY, T-A-Y. And it was famous some people say infamous, chatbot developed by Microsoft. And unfortunately, it barely lasted 1 day in the public before it had to be shut down for producing a stream of hateful, racist comments. Machine decided that it was going to answer certain questions based on input, and what came back was really, really, really uncomfortable, to say the least. And Microsoft, in its wisdom, I think, positively said, we got to shut this thing down. Now, there's a lot of pointing of fingers and everything else going on, but the bottom line is that I wholeheartedly believe, and I'd stand next to the president and the CEO of Microsoft if they wanted me to and say this. I don't think Microsoft intended by any way, shape, or form that this be done. However, it happened. It happened. And there should be a way to trace and find out what happened. And at the beginning of this broadcast, I mentioned those two words, traceability and transparency, which I'm going to suggest is missing. And you can't see these things in 1,000 pages of texts. You can't see these things in millions of lines of code, ladies and gentlemen. You need something different. And some of you who have been listening to this broadcast over the past few months and weeks know what that is. A set of blueprints, parentheses, architecture. You've got to have a baseline for addressing and managing change and managing the understanding of what's going on in a human consumable format. If you got a bunch of running code and you got 7,000 pages of specifications, you're not going to be able to see why or how Tay did what it did, and you cannot guarantee in any way, shape, or form, I'm going to be that direct to make sure it doesn't happen again. And so we've got to recognize where we are in this world, and one of the reasons that this has been going on since the early 50s, and some of you, as I mentioned, 1945, it's a huge issue. But it comes down to the ability to transparently trace and understand transparency and traceability of decision makings in a machine. Machines don't think. Pause yet. Okay, and we'll chat about that in just a minute. And by the way, IBM had a similar experience when it added Urban Dictionary definitions to their underlying platform and product called Watson. And there were some unintended consequences, folks. Unintended consequences. And how do we minimize, what those are? Now, we're enjoying lots of benefits. We, meaning the general community, that's there. Discovering hidden patterns and things that human beings aren't good at quickly, anomalies and opportunities. But these tools rarely provide an understanding of how they derive their understanding and knowledge. And also, there's not an understanding of when that answer may no longer be valid. Think about this for a moment. Things that we did 10 and 20, 30 years ago may not be valid anymore, may not be acceptable. So where is this guidance? Lots of questions that we're seeing here. Now, one of the things that I want to ask you rhetorically here, and if some of you are in organizations, look at the business decisions in your organization that have probably been mechanized. How many of those have been mechanized? What was the logic behind them? Are there algorithms that are there? What are those algorithms? Who put them together? What is the traceability of the answer? What was the base understanding that was actually codified in those computer systems that were out there? What were the business rules, a common phrase that you may hear when it comes to these things that have been mechanized? Are those business rules still valid? Are they legal? Are they ethical? Are they what the organization looks for as far as comprehensive understanding of what is going on? And how do you determine if they're still valid in those particular areas? So forget about looking outside for a moment, but I'm going to I'm going to be betting with a high degree of confidence that most of our listeners have in their organization some kind of decision making or an answer that being provided by some computer system, some mechanization, which is a series of commands that say if this, then that, then if this, then that, then this, then that, then this, then that, and the answer is whatever the answer is. And is that logic transparent? Is it understandable? Can people do that traceability? In other words, can you sit down with those same questions and come up with the same answer? That's the acid test. Let me say it again. You've got a series of, I'll use the phrase, inputs, whatever they are, whatever the decision is, and you come to a conclusion, you as a human being, and you put that same information into your algorithm or computer, and it comes up with the same answer. If it doesn't, then you have to induce what I call the test. That's spelled H-M. Is it, what is it? Why is the answer different, that's out there? And when it comes to these things, there are a set of core values that are underlying this situation. And I'm sure that you see this right now if any of you have seen the debates, and whether it's Google or Facebook or Instagram or banking and decision making and all these movies and things like that are going on. How are these decisions being made? What's out there? And there's a lot of things that people suggest need to be, quote, hidden, if I can use that phrase, for, people say, proprietary reasons, proprietary algorithms that are out there. This is a little bit more difficult. In other words, there is proprietary information on how certain things are done. That doesn't mean it's not traceable. That doesn't mean it can't be looked at to see if there is biases in there. And there is a ton of different phrases that we can use that's associated with that word bias. So do we need some supervision? Some people say we need a little bit of adult supervision around these things that are going on because the children seem to be running the asylum right now in some cases that are out there. Again, I want to stress there's some really good stuff going on, but more and more people are getting a bit uncomfortable with what they're seeing. We sometimes see principles that are being developed. These are very troubling to me in our field of endeavor, which is enterprise and business architecture and the enablement of business strategy as trusted advisors. Principles are just that, principles. It has to be traced to actions. You have to have a traceable and transparent path. So if somebody says one of the principles we have is to be socially beneficial, another principle is to avoid unfair bias, these are nice, beautiful phrases that are out there. And there has to be a demonstrated, traceable path to the actions that the human beings are making, and more importantly, when it comes to artificial intelligence, the computer is making. So how are these statements, some people even use a nasty phrase, these platitudinal statements, get transferred into actions that are there? So when somebody says our website is geared for ensuring the safety of your credit card information, that's a beautiful principle, hard to argue with. Question, how is that enabled? What is the traceable path from that statement all the way down to the actual running computer code? It's a rhetorical question for you and I, but something that the people that are doing this stuff should be able to demonstrate that's there. And if they don't, shame on them. And I'm going to suggest to you pretty strongly that in a lot of cases, there isn't that path, that we see there. Again, traceability and transparency, what we're looking for. And I enjoy, and this goes back to some of the work that was done in robotics early. Do no harm. A robot should be doing no harm. Well, of course not. Once again, a great principle, something I agree with. How is that transformed into a series of algorithms and safety items and sensors and all these other things that go on to ensure that that platitudinal statement actually becomes a statement of intent and a statement of effect, that's there. And so these types of things, especially when we're looking at the world that we're in right now of massive digitalization, are becoming more and more important. And we see a lot of this work and a lot of this questioning going on actually in Europe. And some people say that Europe is a bit more sensitive to these things than we are here. And they've got, for example, the General Data Protection Act, things like that are passed in law to try to codify some of the items that you and I are talking about right now. I'm not pointing to the Europeans as a benchmark or someone that should be emulated, just an example of some of the things that are going on to try to address some of these things that we're seeing, because we're moving from a human-centric decision-making to a machine-centric decision-making in a lot of cases. And that's why we've got the question of, do we need a little bit of human oversight or human or adult supervision to make these happen? So with that bit of an understanding, we're going to just take a short break now. And when we come back from our short break, we're going to be talking about some of the things that we need to address as we're looking at this artificial intelligence approach. This is Sam Holcman. We're talking about artificial intelligence. We'll see you back here in a few minutes.
Are you frustrated with your business strategy, mission, or enterprise architecture efforts? If so, the book, Reaching the Pinnacle, A Methodology of Business Understanding, Technology Planning, and Change, by leading enterprise architect practitioner Sam Holcman, brings a method to the marketing madness that surrounds the enablement of business and mission strategy and enterprise architecture. This helpful, no-nonsense book sheds light on this poorly understood topic. It helps business executives and technology professionals build an enterprise architecture appropriate to their organizational needs, enabling their business and mission strategy. Enterprise architecture is the rethinking of how business and mission planning and information technology can support each other to achieve its strategic and mission objectives through the development of a series of project initiatives and agile models. Reaching the Pinnacle is available at Amazon.com. Is your organization in the internet age when those around you are moving into the information age? Are your hallway conversations filled with words and phrases like blockchain, AI, VR, cloud computing, and micro this and that? Are you interested in bringing some method to the madness? Then talk to us. Through years of consulting with clients all over the world, the Pinnacle Business Group and Architecture's Center of Excellence have developed an understanding of what makes a consultant-client relationship work. And this understanding comes to every engagement. The Pinnacle Business Group assists organizations in solving their business and system challenges with its unique, proven approaches, bringing teams of business and system personnel together to jointly define business and system requirements. The teams are led through a series of facilitated activities to provide innovative solutions to their business and system challenges. We look forward to hearing from you. Visit pinnaclebusinessgroup.com. You are listening to The 2020s Enterprise with Sam Holcman. We welcome questions and comments about the program via email to sam@eacoe.org. That's sam@eacoe.org. Now, back to the 2020s Enterprise.
Welcome back. This is Sam Holcman. You're listening to the 2020s Enterprise. And in this episode, we're talking about artificial intelligence, and the question that we're asking, with a bit of tongue-in-cheek, but not too much, is perhaps it should be called augmented intelligence that's there. And we're talking about moving away from purely human-centric decision-making to machine-aided decision-making. And in some cases, machines are actually making these decisions. And in most cases, these machines, of course, are computers that are there. And within the computers, there is no magic, there is no mystery. at this particular point. There's a series of zeros and ones, which the way computers programs are actually done, zeros and ones. If some of you know how it's actually encoded finally, that's there. And driving those are a series of formulas. Some people like the word algorithms. And basically those algorithms are there to provide a calculation. How do you calculate, for example, just give you a simple understanding here for just a moment. You're living in the state of Michigan. You bought a meal. It cost you $10, and there's sales tax of 6%. So there's an algorithm that says 10% of $10. 6% of $10. Pardon me. 6% of $10 is 60 cents. So I'm going to add to the bill that's required 60 cents, and the total that you're owed for this particular transaction is $10.60. So there's a series of calculations that are done to be able to do that mathematical calculation. Of course, as a human being, pretty easy to check when you look at it. Now let's think about this a little bit broader. Let's say that you're buying a house or a car, and somebody says, I'm going to check your credit rating. And you're going to say, okay, that's one of the requirements, and you sign this statement that says, I agree. Of course, you probably don't read this, and by the way, most of us don't. That's there, and they're going out searching somewhere, try to make a decision, and what's the decision they're looking at? Should we loan this person money to buy a car, yes or no? What's the probability that the person that's supplying you with the automobile, the car dealer, or a friend of yours, is going to be paid in full? That's the question. That's, quote, credit rating, if you want to. And there's a gazillion, sometimes proprietary, sometimes not so fun, sometimes not so unbiased. Hopefully, a lot of times it is unbiased calculations that are going on. And what you'll tend to hear is I can't show you what those calculations are because they're proprietary. I'm not here to argue about that statement and whether that is legit or not. It doesn't matter. That's what's happening. And so you're sitting there, if you got the loan, happy. If you didn't get the loan, you're unhappy. And the algorithm said no, and perhaps a human being can intervene. So let's say that happens. The salesman and the manager of the finance department at the dealership says, this person's bought 3 cars from us before. I don't care what the algorithm says. We're going to give them that loan. Everybody's happy. Now let's go from the positive. Everybody's happy. Let's say 3 months and 4 months later, you stop paying. Now those people are unhappy because they went against the algorithm. They went against the history that was out there. So when you're making decisions that go against the computer, you actually have to defend those decisions in most cases right now. Isn't it interesting? The computer, by definition, is 51% correct. And the people now have to prove it incorrect. Let's keep going here for just a moment. Okay? All of that is algorithmicized in computer code. Somebody actually is writing a series of commands. If this and that, look at this, grab this piece of data, multiply by 0 and have the right answer, that's supposed to be funny, and do this and grab this from this source, et cetera, bring it all together, mush it all together, and come up with an answer, yes or no. And those things are written by human beings. The computer programs, the code, the language is written by human beings that are out there. And we have to recognize that those algorithms are not 100% neutral because somebody is taking words, whatever they are, and converting those into computer language, which ends up in zeros and ones. Please don't get me wrong. I'm not suggesting that programmers and technologists are nasty and biased. It's not what I'm even suggesting in the remotest approach, in fact. But, once again, B-U-T, but, comma, we have to recognize that there is a human being involved that's translating those thought processes, whatever they are, into a series of zeros and one algorithms and coming to a conclusion. Once again, we need to have traceability and transparency from the embedded decision-making algorithm or code or whatever you want to call it, all the way back. And we have to recognize that these algorithms are built with hypotheses about relationships between a person and what they're doing and a thing. So if we're buying an automobile for $40,000, XYZ. If we're buying a bag of potato chips, different situation. Same if statement, so to speak. So somebody says, if Sam is borrowing more than $40,000, unfortunately, he's not creditworthy, whatever the algorithm says. But if he's buying a pack of gum for 50 cents or $1, yeah, it's no problem at all. Authorize the charge card transaction. Well, just think about that for a moment. Is that the right number, 40? What about a $30,000 car? What about a $20,000 car? What about a $34,595 car? Please notice that all of that stuff I'm talking about, hopefully talking to you in a human consumable approach, somebody is putting that together in the series of mathematical functions that are making decisions on things that are out there. And what we have to recognize is that the people doing this are software developers. And they're probably not well versed in issues such as fairness, unbiasedness, civil rights, ethnic clarity, making sure that things are out there. And that could be conscious or unconscious. Again, I'm not suggesting at all it's evil. We have to recognize once we throw the human element in there, which we're going to do, which is wonderful. And so in this area, we have to look past this and recognize there's a series of things that may affect those algorithms that are out there. Now, people can use the term bias. These are biases that are out there. I'm going to prefer to say these are a series of characteristics in which decisions are made. And these are not in any order. And this is what we have to recognize. So when we're looking at artificial intelligence, we have to recognize there's a series of things that are making these decisions, and these things I'm going to try to enumerate now to get you to understand a little bit about how this is all working. Because there isn't any magic going on. I know it sometimes looks like magic. Oh, look at that decision that was made, but it's not. The first, and probably the most difficult, is what is used to actually train the algorithms. In other words, what data is there to begin the process? How do they know that I have a certain creditworthiness? What is the information that is fed? What is it about me that they compared to other people and to other approaches and to other years and to other transactions and to other whatever it is to make a decision that in this particular transaction, it's okay or it's not okay that's there. We call it training data. And of course, it has positive issues and could have, biases. And a lot of you, of course, have been watching, various newscasts and television programs, are seeing a lot of this come to light when it comes to the criminal justice system. There isn't a day goes by where there is a belief that part of the algorithm that does the sentencing, the decision making that's presented to the judge, which is great, of which the judge has some leeway, not 100% in most cases, that's there, is based on the criminal justice system data, and the criminal justice system data is biased. I'm just giving you one example. I'm not trying to pick on the criminal justice system. So you can see that path. Well, if the criminal justice system is biased, that means the algorithms that are going to come up with essentially the sentencing is going to have that same bias in it. So we have to recognize that, and we have to figure out how to mitigate it. And once again, maybe we need some augmented intelligence where the judge has the final say, not the algorithm, that's out there. And we have to look at it. Now, we can look at another item. So it's the data that's been training. And now we have the algorithm that was put together. So we have the data, and now we have what's the mathematical, what parameters are used to make those decisions that are there. And boy, is this a hornet's nest, sometimes. And I'm trying to be as obviously as sensitive as possible to these types of phrases. I mean no one any harm or any type of exclusion or inclusion. But for example, should gender and race be involved in these things? How do you address those? Once again, and how about zip codes? In other words, postal codes. How about financial situations, that are out there? How about the number of parents you have, the number of siblings you have? You can go on and on and on. So the algorithm, in other words, the parameters that are making these decisions, we have to make sure that they are as, quote, clean as possible. When I mean clean, once again, traceable and transparent to figure out what is going on. And then we can essentially have context that's there. Okay? Context. So you have a credit score. And in somebody's algorithm, you're going in for a job. They say a credit score has an influence on a hiring decision. Somebody's made that decision. So in their algorithm for hiring you is credit score. Rhetorical question. Does that have anything to do with hiring? Does bad credit or good credit equate to inferior future job performance or superior job performance? What was the logic behind that? What was the traceability? Is there any evidence that has anything to do with those things? And of course, when you come up with the answer, finally, there's an interpretation that goes on. So is there an understanding of the logic of interpreting the actual numbers that's there? And what we're actually looking at as the end game is this concept of, once again, transparency and traceability. So when an algorithm recommends the denial of a loan application, or the algorithm recommends not hiring somebody, is the person that's conveying that to you, do they have the understanding and the ability to tell you here was the logic and the traceability of why these decisions were made? Some people may say it's none of your business. We've made the decision not to go ahead with the transaction. If you don't like that decision, go somewhere else. And of course, some of you have probably witnessed, unfortunately, I have myself, by the way, I'm a white male, but years ago, because of my religious background, we were denied some things in our family, and it was quite upsetting. And I don't know if it was 100% or 20% due to religious convictions or not. Don't know. But there was a suspect situation, that was there in part of that decision-making outcome bias, because the algorithms possibly put 2 and 2 together and came up with a number 3 or 7, that's out there. And when it comes to gaming the system, there's people also that are going in there and deliberately trying to do things, evildoers, hackers, whatever you want to call it. And coming back to this, the product that Microsoft took off the market after a day, this thing called Tay, the chatbot, a lot of people were convinced that Microsoft released this in a test mode for people to take a look at. A lot of people were convinced that, a bunch of these evildoers got together, and I'm not joking about this, and actually taught the product nasty things. They may have thought it was funny or not, don't know. But again, once those things are out there, if it's a teaching process, where's the teaching information that's there? So these are some of the things that we have to watch out for. And in our last segment, we're going to be talking about a little bit of this historical perspective to give us an idea where we can go from here. You're listening to Sam Holcman. I can be reached at sam@eacoe.org, sam@eacoe.org. We're talking about artificial intelligence. Take a quick break, and we'll be back here in just a few minutes.
Are you frustrated with your business strategy, mission, or enterprise architecture efforts? If so, the book, Reaching the Pinnacle, A Methodology of Business Understanding, Technology Planning, and Change, by leading enterprise architect practitioner Sam Holcman, brings a method to the marketing madness that surrounds the enablement of business and mission strategy and enterprise architecture. This helpful, no-nonsense book sheds light on this poorly understood topic. It helps business executives and technology professionals build an enterprise architecture appropriate to their organizational needs, enabling their business and mission strategy. Enterprise architecture is the rethinking of how business and mission planning and information technology can support each other to achieve its strategic and mission objectives through the development of a series of project initiatives and agile models. Reaching the Pinnacle is available at Amazon.com. Is your organization in the internet age when those around you are moving into the information age? Are your hallway conversations filled with words and phrases like blockchain, AI, VR, cloud computing, and micro this and that? Are you interested in bringing some method to the madness? Then talk to us. Through years of consulting with clients all over the world, the Pinnacle Business Group and Architecture's Center of Excellence have developed an understanding of what makes a consultant-client relationship work. And this understanding comes to every engagement. The Pinnacle Business Group assists organizations in solving their business and system challenges with its unique, proven approaches, bringing teams of business and system personnel together to jointly define business and system requirements. The teams are led through a series of facilitated activities to provide innovative solutions to their business and system challenges. We look forward to hearing from you. Visit pinnaclebusinessgroup.com. You are listening to The 2020s Enterprise with Sam Holcman. We welcome questions and comments about the program via email to sam@eacoe.org. That's sam@eacoe.org. Now, back to the 2020s Enterprise.
Welcome back. This is Sam Holcman. You're listening to the 2020s Enterprise. And today in the episode that we're doing with you today, we're talking about artificial intelligence. And the title of this episode was, perhaps we should call it Augmented Intelligence. That's been the theme of what is going on there. Let's take a look at the term itself for just a moment and why we say this. And the artificial intelligence world has been studied for decades by who? Basically, initially, and majority of the work right now going on in the research is computer scientists. Wonderful people. Wonderful people. What about the human element? So what about the soft side of the computer? It has none. So the human beings also need to have artificial intelligence in the work that they do. So do the software developers recognize that it's more than an algorithmic technical problem? Do they have to? Should they? And do they care? It's an open-ended question. And that's one of the reasons why we suggest the word augmented intelligence is probably the pathway that's there. I don't want to use the phrase I'm going to because it's funny. Maybe we need a little adult supervision outside of IT when it comes to artificial intelligence. Not that IT people are bad. I'm one of them. I hope I'm not bad. But perhaps a secondary view. Now, I'm not talking about the, kumbaya type of approach that's there, that everything that computers do is negative, but it's recognizing that we are affecting human lives, human businesses, decisions being made that are out there, and perhaps it needs to be looked at, researched, discussed, talked about outside of the computer science curriculum and organizations that are there. And a lot of that is happening right now, which is actually, fantastic. As we look at. And what we have to recognize, it's hard to argue about the computer's ability to process logic. Let's look at that last word, logic. The assumption is what is being processed is logical because it's a series of commands. Okay, now, one of the debates, that's why I was trying to do a little caution, is can the machine think? Now we have to look at the definition of what thinking actually is, that's there. And there's a lot of definitions. Now what it can do is calculate quickly. There's no doubt about that. But can it think? And that word itself, if you want to look it up, that's fine. But what does that actually mean? Thinking, I think, is different than making a decision, that's out there. I think that a computer can look at things, facts or data. And the computer can't make a decision generally if it's a correct fact or incorrect fact. Now, there's some things that are going on, but can it understand? Can it understand? And if it can understand, then I think it can lead to thinking. So I'm sorry to be a little bit obscure when it comes to these phrases, but I want you to think about this problem that's there and why, again, augmenting of intelligence, your and my intelligence, is probably the path that's there. Because right now, everything that we've seen in decades, and I think you'll agree, every time you hear the word AI or artificial intelligence or machine learning, the expectations are much greater than the actual delivery that's there. And that's not a marketing problem. It's just something that we have to recognize. Okay, and MIT has done some fascinating work in this particular area, and Nicholas Negroponte, one of the co-founders of the Media Lab at IBM, had said, quite some time ago that the value of a thinking computer is more in its ability to work together with a human being instead of passing an interrogation by a human being. In other words, we're not interrogating the computer, we're actually working. So rather than having the human being interrogate the machine to see if it is a human as well, maybe we need to look at the computer to say, can the machine help the human being reach their goals better than if they do it on their own? I really like that. That particular test is the augmentation of our skills, your skills, using mechanical devices. And to me, I always like to look at the physical world and look at the analogy. And probably most of you, all of you, have a toolbox in your home of physical tools. You have hammers and you have screwdrivers and you have saws, and some of you may have power saws, and you may have jigsaws and saber saws and all these other types of saws that are out there. What are they actually doing? They are helping you. They are aiding you. These machines are helping you do things. Perhaps we got to look at this stuff the same way. That's what I want to do right now. Rather than arguing about these things, we need to look at it as an aid for us in decision making, not a replacement for decision making that's out there. Now, some of you may say, well, Sam, there's a lot of machines that do stuff on their own. Be very careful with that phrase. They don't do things on their own. A human being has once again programmed them to do something. It's going to mix ice cream, okay, or it's going to carve out a door panel on an automobile. It doesn't do it because it doesn't have anything else to do. A human being has said, a machine is going to take a piece of metal, it's going to put it into this particular holder, and through a series of 753 different steps, out comes essentially a door panel for an automobile. It's not doing any thinking. It's aiding us in producing essentially products. It can't do it on its own. What people think about is it can do it on its own because there's nobody there helping it. Well, all the help was done before. So it can do repeated actions based on the wisdom of the operator of the computer. Once again, it's aiding it. And this is what I want to think about when it comes to artificial intelligence. Again, the phrase, augmenting my intelligence, helping me work on this. And along the way, in the last couple of segments, I talked about some of the issues that we have to look at to make sure that that help is actually positive and not causing angst for ourselves or other people, that are out there. And that's kind of hard. And we're seeing, in a lot of cases, the negative sides. Now, there's actually two kinds of, quote, thinking, unquote, that we have to think about when it comes to artificial intelligence. A lot of times people look at things like probably the most common thing people think about are chess games. You see this a lot. The computer beat the grandmaster in chess. Okay. The question is, how did that happen? And let me say this. The best chess playing computer really does not understand the concepts of the game, but it's relying on brute force speed to make its decisions. It can do if-then analysis very quickly. If this, then that. If this, then that. And this, then that. And so the brute force type of, quote, AI is what most of us see, and right away we make that jump, that's out there. And so the reason the computer can play chess and beat the grandmaster a number of times is because the computer can examine thousands and thousands of chess moves very, very quickly in comparison to a human being. That's the brute force AI, if I can use that phrase. Okay, which is very different from augmented thinking, the thinking machine learning, which is a different type of understanding where it's looking at it very, very differently. It's making, quote, not brute force decisions, but looking at things heuristically that's there. And that level of understanding has yet to materialize that's there. I'm not knocking any of this. I'm just giving you some positioning, that is going on. Okay. So we may be threatened by the computer beating the chess champions, but that's sort of like a scientist named David Stoke came up with what I think is a great example. Okay. That's like saying, oh man, geez, what are we going to do? And his example is just like saying a motorcycle can beat an Olympic sprinter. Well, of course it can. Duh. Well, of course it can. And that's not what we're looking at. That's not what we're really thinking about augmented intelligence, artificial intelligence. So keep in mind, as I said, when it comes to this topic, the problem is, and the benefit, the problem is we have these, quote, algorithms, and the computer can do these things quickly. And that's why the last segment, I think, is so important. We have to recognize that since it is algorithmic and not, quote, free thinking, that in the algorithms, we have to make sure that there is no bias. That's really what we're talking about, that's there. And so in the computer example with chess, for example, the machine was called Deep Blue, if you remember. It was evaluating about 200 million chess positions a second. Whoa. That's out there. So we have a situation where right now in the fields that you and I are talking about when it comes to the word artificial intelligence, there's really two things going on. The brute force approach, which is a massively high percentage of what people think and call artificial intelligence. I'm not here to argue about what you're calling things. The other side is the thinking machine that's out there. And I think we're quite a ways away from there. So the question for us is, can computer algorithms, because they can do things very quickly and accurately, help you and I, our businesses and our enterprises, in making decisions that are better and faster and more effective? The answer is yes, unequivocally. But in order to do that, once again, the but, unfortunately, we have to recognize that those mechanizations are based on a series of inputs, data inputs, and those inputs have to be understood in their context and to ensure that the decisions that are being made are based on the best, unbiased, unleading set of data that's out there that is then mechanized by a series of technologists and programmers. And that type of thing is where we're possibly getting ourselves into a little bit of trouble in pure AI, and that's why I really think in the next decade or so, what will really help us and really push the field forward is this concept of augmenting your skills and my skills using technology in a series of algorithms. Just like we did in the industrial age that we're coming out of and going, of course, into the information age, as we're leaving the internet age and going to the information age now, even more quickly, we augmented our strength in the industrial age using machines and screwdrivers and hammers and saws. And we started off with manual saws and then went to mechanical saws and things like that. I see that same path, ladies and gentlemen, with computer algorithms and augmenting our ability to make decisions. And what we need is architecture to allow us to look at a transparent and traceable path from the thoughts and the understandings to do a certain series of calculations to ensure that those calculations are unbiased and actually serve both the customer and the organization well. I hope you found this episode interesting and looking beyond the pure chess type of artificial intelligence. We call it augmenting intelligence. Thanks for listening. I'm Sam Holcman. Please reach out to me. Be more than happy to chat with you about this and many other topics that we've discussed over the past few months. Have a great afternoon. Have a great evening. We'll see you next time.